Welcome to the cloudonaut podcast. My name is Andreas, and you're listening to Volume 1 of the AWS-to-go series. Get started with AWS or broaden your knowledge while walking, biking, running, driving, or whenever you enjoy listening to podcasts. There are three things I want to highlight before we get started. First, I want to welcome Steffen to the show. Steffen is a web and front-end developer. He just gets started with all things AWS, and that's exactly why we have Steffen here to ask questions on your behalf. So welcome to the show, Steffen.
Thank you, Andreas. Hello, everyone, and thanks for having me.
Perfect. We are very glad to have you. And second, the AWS-to-go series is based on our book, Amazon Web Services in Action, published by Manning. We are currently in the progress of writing the third edition. The first chapters are already available for reading, so get a copy today and check out the show notes for details. And the third is AWS expertise is in high demand. For example, our partner TechRacer is looking for cloud consultants and cloud migration specialists. TechRacer is 100% focused on AWS and has offices in Hanover, Duisburg, Frankfurt, Hamburg, Munich, Vienna, Lisbon, and Lucerne. Check out the show notes for details about the open positions and apply today. So with all of that, let's get started. The topic for today is, what is Amazon Web Services? If you want to follow along, check out chapter 1 of our book, AWS in Action. So Steffen, I know that you have got a little bit of get to know AWS a little bit already. So maybe before we start, so what would you say is Amazon Web Services?
Good question. AWS, I always imagine like this computer from someone else who's just hosting everything for me. So this computer which lives somewhere else, but is basically doing stuff which you could also do by yourself.
Mm-hmm. Okay, very good. Yeah. So that's I think that's gets it already very good. So I have a more official definition of what you have been describing, and this is from the National Institute of Standards and Technology. And basically, what they say is cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. So that basically means that over the network, we have access to a wide variety of services that we can use to build whatever we are going to build. And maybe to just get some terms right before we dive into what is Amazon Web Services. So typically, cloud computing offerings are divided into three different types. So there is public cloud providers. So basically, this is an organization is providing cloud services to more or less the general public. So that is what we call public cloud. A private cloud is basically when you try to build your own cloud for your company, for your organization. So that is often a virtualization layer, maybe a container cluster, something like that. And it's just used for inside the organization. And then you'll often hear the term hybrid cloud, which is basically a mixture of both things. So it's basically having your own stuff on premises and also using a public cloud provider. And so when looking at those three different types, it becomes very obvious that Amazon Web Service is a public cloud provider, because Amazon offers that service to basically all of us that have a credit card and are able to pay for it. Okay. But besides that, cloud computing is often classified into several categories. For example, we have the one very popular part of cloud computing is infrastructure as a service. So that is, for example, I want to spin up a virtual machine on demand, and the machine needs maybe a little storage and stuff like that. So that's infrastructure as a service. It feels like you get access to a data center and you're able to spin up your machines there without really touching anything. It's just a virtual thing. And then there's one layer of abstraction above that is the platform as a service. And for example, you might have heard about Heroku, or Google App Engine was very popular. And this is basically a cloud provider providing the infrastructure for running your own applications in the cloud. So basically all you have to do is you have to provide your source code, and then the cloud provider takes care of the rest. And then there is software as a service, which is basically bundling those two things together. You get the infrastructure, but you also get the complete software running on top of that, providing the whole service out of the box. So examples for that are maybe Microsoft Office 365 or Google Apps and stuff like that. So, or Dropbox might be a good example as well. So those are the different categories. And with AWS, so when you log into the management console for the first time, there's a huge list of services that AWS provides. I haven't counted them, but it's really a lot. And they basically cover all those areas. So it starts with infrastructure as code, but they have platform as a service, they have software as a service, and many other offerings as well. So it's really a very broad portfolio that AWS comes with.
I've seen that, yeah. It's a huge list.
Yeah, it's a little bit frustrating or frightening at the beginning.
Yeah.
At least that was what I've been feeling.
As a beginner, you definitely feel kind of lost.
Yeah, absolutely. But to avoid that, this is exactly the podcast episode for that. So we will dive into that later. Okay, so now we try to get some definitions right. And the problem with all those definitions is there's a lot of marketing buzz involved when talking about cloud. And so it's sometimes a little bit hard to get the right term for a thing, because it's often such overloaded terms that it gets hard to really discuss the details. But yeah. So what is Amazon Web Services? So Amazon Web Services, what I would say, is a platform of web services. So that's in the name, web services, that offer solutions for computing, storing, networking at different layers of abstraction. So we talked about that already. So we have really infrastructure as a service offerings like virtual machines or block storage. And we also have higher level services like an object store. S3 is, for example, very popular. And we have even things on top of that. For example, there is something like Dropbox provided by AWS as well. So there are really different layers of abstractions. And at the end, it all comes to compute, storage, and network, right? Because that's what all of IT is about. Okay, so, and another important concept of AWS is AWS runs data centers all around the world. So as a customer, you're able to choose one of those data centers. They call it also regions worldwide. And you can basically select where you want to store and process your data. So that is, of course, important because of the latency, because the longer the distance, the higher the latency over the network. That's just physics. But it's also, of course, important because of laws, regulations, and stuff like that. So, for example, as Europeans, it makes a lot of sense for us to use data centers in the EU, because then the GDPR and everything gets a lot easier than, for example, when we processing data in the US. And the other way around is probably true as well. So the data center. Sorry.
So is this guaranteed? So if I say, like, I want to choose, I guess Frankfurt is one of the data centers in Germany. If I choose Frankfurt as the data center, that AWS is not shifting my data to the US because maybe Frankfurt is like currently out of service or whatever.
Yeah, that's a very good question. So yes, AWS is guaranteeing that the data is stored and processed in the region that you are selecting for the service. There are features that allow you to move data around between different regions. But that's always something you have to configure and enable yourself. It's not something that happens magically in the background. So let me give you an example. For example, S3, the object storage, has a feature to replicate data from one region to another automatically for fault tolerance, for example. But that never happens automatically. there are a few areas, very few areas. For example, the machine learning stuff. There are some, very specific areas where you have to opt out of something like this, but that's a very rare case. So in general, it's definitely true that AWS does not transfer data without your knowledge to other regions.
That's cool.
Okay. So yeah, the different regions are very important. So with the regions, it's a little bit like with the services that AWS provides. They're adding more and more regions every year, and the number of regions grows and grows. So actually, I lost count about the number of regions. But I think what's important is, I think it's almost true that on every continent you find at least one region. So of course, there's a lot in the US, in Europe, but there is also a region now in South Africa, in Brazil, in Australia. Of course, the APAC region, the APAC area is also covered with a lot of regions as well. So I think really the whole the whole world is now covered with data standards by AWS. And what is important to know is almost all of those regions are just ready for you to use with the click of a button. So that's really cool. It's really easy to just spin up a new virtual machine, for example, in Japan. So that feels really like magic when doing that. There are only a few exceptions to this rule. So there are a few data centers and regions that AWS offers only to US government organizations. So that's, for example, nothing we can use out of the box, of course. And then the China regions are also limited because there's some legal stuff going on there as well. So those are also not available to everyone. But the others are just available to all customers.
Nice. So if I got that right now, AWS is this public cloud. I can't repeat the definition from the National Institute.
Me neither.
This was a little bit complicated. But it's like this public cloud service where I can host my infrastructure, computing stuff, or I just can save my files there. I can use it as a platform if I want to host my apps or whatever. Or I really can just use it as this software as a service, you said. Where I guess there are a lot of, the most popular examples you hear which are using AWS are software as a services like Office 365. I guess Netflix is also on AWS, correct me if I'm wrong.
Yes, but those are services that are not provided by AWS themselves, that are just the customers running their infrastructure there. So let me give you an example for a software as a service offering at AWS. One is Amazon Connect, which is basically a call center solution running in the cloud that you can just use. So basically you get a web overview and then agents can connect and take phone calls there. So that's a full solution for a specific problem, and it's the software running on the AWS infrastructure and even connected with the phone lines. And that's available for you out of the box. So you don't have to install anything or write any code. It's just a ready-to-use solution that you can use, software as a service offering. That's what I meant by software as a service offerings from AWS.
Okay. Got it. Yeah.
Okay, but you're bringing up a good question. So the question basically behind that is, what can you do with AWS? And so we already discussed that there are a lot of different services that AWS provides. So the possibilities are almost endless, probably. But I want to go through a few very common scenarios of what you can do with AWS. So, for example, the first one is hosting an e-commerce shop, a web shop. So what you need for that is basically you need a server running your web server, basically. So I don't know, running your PHP files or what have you, or Ruby or what have you. You need a database, a SQL database, typically. And then you also need probably stuff to publish or distribute static content like images, JavaScript files, and stuff like that. And so in the on-premises world, in the data center, you probably had one or two or maybe three virtual machines running that were doing that job. They were connected to the internet, and then users could connect to those machines, and you have been running your Apache or Nginx or what have you on those machines and serving the requests. When you move that workload to AWS, so just to give you an example of what a typical architecture would look like is, you would start with virtual machines. So that's infrastructure as a service offering called EC2. You can spin up your your virtual machines there to run your web servers. So that is more or less similar to what you have in a data center. But then you also have, for example, a managed service providing a SQL database out of the box. So that's something that is different to running it on premises, because AWS provides that service for you. The database service called RDS is making sure that all the maintenance stuff of the database is taken care of for you. You just have basically to provision the database. Then AWS comes with a load balancer, for example, to make sure that you can distribute incoming requests among multiple machines. And there is even DNS, so domain names and all that stuff coming as a service from AWS. We have a content delivery network that you could use to make sure that your static content is delivered to the users really fast, for example, for the product images of your web shop. So you already see that there are a variety of services that can work together to basically solve a solution, provide a solution for, in that case, hosting an e-commerce solution, a web shop on AWS. So that's one example.
Okay, so you mentioned domains for a second. Did I get it right that I can not only host all my data on the AWS and my web shop, but that I also can register my domain, which I would like to set up for the web shop directly through AWS?
Exactly, yes.
And the database is like, I set it up and I don't have to do manual backups or anything of that. It's all taken care of.
And that's a huge benefit, especially the database part is very, very important to make sure that someone else is responsible for all that backup and restore functionality, and nothing can go wrong with that. Because when you do it your own, and I've done that myself, you have always the risk of losing data very easily.
Yeah.
That's a good summary. And then I think that's the most typical scenario. So a web application, a web shop running on AWS, right? So we discussed that. But there are other scenarios as well. So my first touch with AWS was basically we were migrating the IT infrastructure of a small bank in Germany to AWS. And so what I learned about AWS at the beginning is that there is the concept of virtual private networks as well. So I didn't expect that actually, because back then, almost 10 years ago, all I knew was that you could basically buy virtual machines from a provider, but the virtual machine was just having a public IP address, and that was it. There was no networking configuration controllable with those offers typically. But with AWS, there is the possibility to define your own private network in the cloud. And this basically allows you to, let's say, lift and shift, to migrate existing enterprise applications to AWS as well, because you basically are able to connect your corporate network with the private network in the cloud on AWS. And that's another scenario, very common scenario for using AWS, is basically extending your corporate network to the cloud, for example, by using a VPN gateway, or even there's something called Direct Connect to basically make sure you're connecting your corporate network with AWS. And then you can run your workloads there as you have been running them in the on-premises environments.
What was the concrete example? What your local bank was running in AWS then?
So one example there was a very, I would say, very typically Java enterprise application with a Java server, and then Java clients connecting to the server. And we were just able to move that to the cloud. And there again, the database service was very important because again, the database service allows you to provision a database in a private network that is only available within that private network, cannot be accessed from the outside in any way. So that was is also a very typical example for using AWS. Maybe another example with AWS and cloud computing in general is what is very interesting is that cloud providers typically bill you per usage, and that's what AWS does as well. So for example, for virtual machines, that means we are paying only for the time that the machine is running. So what this makes, that provides, or to make use of that is, if you have something like batch processing, let's say, I don't know, at the very beginning of the month, you have to calculate a lot of reports, for example, and you need a lot of compute power to make that happen. So what you can do with AWS is basically, instead of running a machine 24/7, you could only spin up a machine during the time where you do the batch processing. And instead of running only one machine, you can basically start 100 machines only for an hour. And it basically costs you the same as running one machine for 100 hours. So that makes basically scaling out for a short period of time a very competitive advantage. And for example, for batch processing, this can be really interesting. And we have implemented use cases like that on AWS. So that's another example for what you can do with AWS.
Yeah, that's pretty interesting, because I guess if you have like your own infrastructure in your company at home, then, and if you have something like, okay, we need this one time very huge highly scalable infrastructure, then you probably need to buy servers and stuff like that. And then the rest of the year or the rest of the month, they are just standing in your cellar and doing nothing.
Yeah.
So this is really a cool thing.
Absolutely. Yeah. And that actually brings me to the next question, which is, how can you benefit from using AWS? So basically the question, why should you use AWS? And I came up with a list of a few important things, and I want to quickly go through that. So I would say the first benefit of using AWS is that AWS is a fast growing and innovative platform. So I'm following an RSS feed that lists all the announcements that AWS makes about all the services they're doing, and where they basically announce small features or complete new services. And in 2021, I've counted through the whole list, and it is more than 2,000 announcements that AWS made. So that's of course very small features sometimes, but sometimes really new services. And you see a little bit from that number that really a lot is going on AWS, and they are adding new services and features at a very high pace. And the other thing is also they are growing their revenue a lot as well. So that means you benefit just from the fact that the whole thing gets bigger and bigger over time, which also means they are able to reduce costs for things like data centers or machines and stuff like that. So I think that's an important benefit. The other one is when you go to AWS, it's quite common that AWS provides a service for the problem that you have. So for example, you might have the problem of sending mass emails to your customers. So there's an AWS service for that that makes sure you're not getting into the spam folder for the users. Or you have to store huge amounts of files, for example, and you want to have a flexible way to do so. There's a service for that. Or you want to have a load balancer in place. So there's a service for that. So basically, when I design an architecture on AWS, I'm going through AWS and looking for services that solve the problems that I have and just try to integrate them together. And that's a very powerful thing because you don't have to reinvent the wheel for typical things that many developers have to accomplish and need to operate as well. So that's important. Then the other important thing is, as the name implies, AWS Web Services, you can control all those services over the web, which means they have an API that you can use to basically automate all the stuff that you're doing on AWS, which means you can basically spin up a whole data center with virtual machines and everything with the click of a button by making use of automation tools. And that's very powerful. So there's no need to, press any buttons manually or stuff like that. So you could, if you want to, use an API to automate all the things. And that's a very powerful concept. And we will talk about that later in this series a lot. The other one is, we touched that a little bit already, is the flexible capacity. So that's what we talked when we talked about the batch example. And so whenever you have workloads that are not requiring the same amount of infrastructure 24/7, what a public cloud provider like AWS allows you to do is basically you can scale your workloads based on demand. And you are then reducing your costs during times of low load, and you add capacity during times of high load, and are paying for that only for that amount of time. So think about, for example, applications that are used during office hours only. So you can basically almost shut them down over the weekend, for example. Or things like e-commerce, which is booming during Christmas and is on much lower load the rest of the year. So those are all examples for workloads that can really benefit from that scalability. And another one is the reliability, and that was basically, so I talked about that already. So the first thing that I did with AWS is basically migrating IT infrastructure of the bank, and the reason why we came along AWS was actually because AWS provided multiple data centers with near proximity, which means it is very easy with AWS to spin up two servers in two data centers that are, let's say, a few kilometers away from each other. And by doing that, you can increase the reliability, because in the rare case that the data center suffers an outage, the other data center nearby can basically still handle the workload for you. And it's not only the infrastructure that AWS is building for failure, basically, it's also the services on top. So many services provided by AWS, they're just fault tolerant by default, which means even if a whole data center fails, the service will stay operational and will be able to serve requests. So that is a really powerful thing, that it's hard to implement the self level of reliability yourself.
Mm-hmm.
Okay, so another example is when using AWS, we touched that as well a little bit, is very cool benefit is the global infrastructure. So whenever you serve customers worldwide, making use of AWS helps you to also spin up your infrastructure all over the world, which allows you to get low latencies, to make sure you comply with regional data protection requirements and all that stuff. And for example, we've worked with a consulting client that is rolling out the same infrastructure, the same application basically, in different regions for different customers to make sure that they are using a data center nearby actually. And the cool thing, because of the API and the automation that we covered before, is you can do the same thing many times with automation, which means if after you set up your infrastructure for one region, you can just copy basically that to another region very easily, which allows you to roll out your infrastructure globally with very little effort. That's another very cool thing about AWS, I would say.
Yeah, so if I like this one is very interesting. Like if we look back on this example of this web shop, And if you have this like international wide web shop, then basically what you're saying is that I could host my web shop for the US market in the US, and store all my US customers there, while for the German market or the European market, I could copy everything and host everything for the German market in Frankfurt, for example.
Yeah, exactly. And the even better thing is that the effort to manage this infrastructure in multiple regions is low when you use automation by making use of the API. So it becomes much easier than it has before, when you had to provision service in different areas. So yeah, I think that's a really important benefit. Okay, so I want to close there are other benefits, I would say, but I think we covered the most important ones. So I'd love to jump to the next part, which is an interesting question. How much does it cost? So how much does it cost to make use of AWS? And the question...
The most important question.
Yeah, but the answer is very complicated. I can tell you that in advance. Of course. But let's start at the beginning. So overall, your AWS bill is similar to an electric bill. So basically, the services are billed based on usage. So you pay for what you're using. So for example, you pay for the time the virtual machine is running. You pay for the storage that you're consuming, or you pay for the number of load balancers, for example. So you're only paying for the things that you're using. But the question is, how is the definition of usage? And that is different for every service. And there's basically a pricing model for every service. Luckily, nowadays, there is a thing called the AWS pricing calculator. This is basically a tool that you can use, basically a very complicated form that you fill out. And it basically gives you an estimate about the costs of an infrastructure. So basically, you can add something like, I have 2 virtual machines running 24/7. I have a database running. I need so that much of storage, stuff like that. And then it calculates the number. So that is a very helpful tool. I will recommend at the very beginning of this question and this section. Another important thing to know is that there's a free tier that AWS offers. So this is very different for the different services as well, but it means that you can use many of the services for free, basically to test out, to play around with AWS, to get familiar with AWS. You can use the free tier. And within our book, AWS in Action, we are making use of the free tiers wherever possible, and it covers most of the examples we do. And basically, to give you a few examples, so what you get is, for example, you get, for example, a very small virtual machine for free for 715 hours. So, for example, that is included in the free tier. Or you get 5 gigabyte of storage on S3, stuff like that. So there is...
I'm aware of this. I'm not sure if this is still the case, but I've signed up like my AWS account a while ago without doing anything. And then I got myself an Alexa. And there they asked to develop some Alexa skills at the beginning. And I'm not sure if it's through this Alexa developer account or maybe it's also included in a normal AWS account, but that you have like free Lambda services until 1,000 requests or 1 million or something.
Yes, the free tier is really complicated. So there are some of the free tier offerings are basically kept and only valid for the first 12 months after you sign up. And others, like the one that you're mentioning, for example, Lambda, those are basically valid forever. You get that every month. So there's a certain amount of usage for free every month, forever, basically. So it depends really heavily on the service that you're using. So unfortunately, it's a little bit frustrating to get your head around that. But one way to make sure you're not surprised about an unexpected AWS bill, one thing that I can recommend is creating a so-called budget alert to keep track of your AWS and even of your forecasted AWS bill. That is really helpful to avoid problems like that, for example, by accidentally keeping a virtual machine running that you wanted to terminate or something like that. So that's something I can recommend. I will put a link in the show notes that links to how to do that. Okay, but yeah, overall, as we said, the services are built per usage, and I want to go into the example that we had at the very beginning, a typical web shop running on AWS. So how are different things built? So let's start with the database. So with the database, you're paying for the storage that you provision, and you're only paying for the time the database is up and running. So that's the thing for the database. It's very similar for virtual machines. Here you also pay for every hour, or basically it's every minute of the virtual machine running, and you're paying for the storage that is attached to the machine as well. Then we have the load balancer. And with the load balancer, you also pay for every hour the load balancer is up and running, but you're also paying for the traffic that is going through that. Similar thing is true for the content delivery network, for example, for your static content. Here you also pay for the traffic, but there's no fee for the hour or the minute here. So that's a different example. Or when you store things on the object storage S3, you're paying for the storage that you use, and you're paying also for the traffic that goes through that. So what you can see from this very simplified explanation is, for each and every service, the billing is a little different. So for some you pay per hour, for some you only pay for the data going through, for the requests, stuff like that. So that is different. But overall, the picture is you're only paying for what you're using. And if you shut down everything and remove all your resources, you're stop paying for it. And I think that's a really big difference to running a data center where you basically cannot sell the whole thing and shut it down for a few days or something like that.
Yeah, so if I got that right, so I pay, for example, for the CDN only if someone is really using this web shop, because then the CDN is providing, let's say, the images. But if there's no request to the web shop, which would be bad because you don't sell anything.
Yeah.
But then I also don't pay for the CDN,
Exactly.
let's say. But I would still pay, for example, for the virtual machines, because this web shop still needs to be online.
Exactly. In this example, when you use virtual machine, that is the case. Absolutely. Yeah. And so that is, but also AWS provides mechanisms to scale the number of machines, for example. So basically you could increase automatically the number of machines during times of high traffic, and then decrease the number of machines during times of low traffic. And then the same would be true. So when traffic increases, also the costs for your virtual machines increase. And when it goes down, the costs decrease as well. So there are different aspects to that. But overall, think about an electric bill and you're basically paying what you're using. And that's the cool thing about public cloud providers like AWS.
Yeah. You mentioned that I could shut down some virtual machines or activate new ones. How fast could you do that? Like, is it more like I need to know on the weekend, for example, there's more traffic, so I need to, let's say, ramp up those virtual machines on Friday? Or is it something which I don't know, we had just this promotion in 1 hour, there will be a lot of traffic.
Yeah, it's within minutes, basically. So you can scale up within minutes.
Minutes even. Yeah. Okay, that's...
And there's a lot details to that. We will cover that in another volume of this series, but it's possible to increase that. I would say it's very common to increase it within, I would say, 15 or 13 minutes automatically. And if you really play it hard, you can do it within minutes, and you can even try to forecast your load with machine learning, stuff like that. But it's really going in too much detail now, but there are options for that as well. Okay. So the last thing I want to discuss in this series is So how do we interact with AWS? So because I think it's important for the mental model of AWS, what I have in my mind is that first of all, AWS provides a bunch of APIs to control the different services. So basically there's an API and REST API for everything. But of course, we as a human, we don't want to talk with REST APIs. So there are, of course, ways to interact with AWS, and I want to go through them a little bit. So the first obvious one is the web interface, the graphical user interface, and AWS calls it the AWS Management Console. And that's basically the web interface that allows you to control, to discover all the available services. And this is a very good way, I would say, to get started with AWS. So I would highly recommend using the Management Console when you get started to see basically, to get a visualization of what AWS provides, the different resources that are available, stuff like that. It really helps to get an understanding of what's going on AWS. But I'd say it's important to know that there are other ways to interact with the API as well. And typically you get to know them later when you dive more and more into AWS. And one important thing is the so-called command line interface provided by AWS. So the command line interface, CLI, allows you to control AWS from your terminal. So basically you could type in commands like AWS EC2 launch instance, and then it will spin up an EC2 instance for you, a virtual machine for you. And the beauty of that is that when you have tasks to do and you repeat them over and over again to accomplish your task, it's much faster to do that from the terminal than while clicking through the Management Console. And of course, you can even start writing scripts. So that's basically my own journey. I started with the Management Console, then I did shell scripts with the command line interface. And you can start automating things that you do over and over again. Very powerful. And then there is CDKs. So that's basically ways to integrate the AWS APIs into your applications. So when you write, for example, Java, Python, JavaScript, Go, Ruby, I think all the main programming languages are covered those days. And so that allows you to write a little more complex stuff than just bash scripts. So that's powerful. And I use it a lot when writing applications that make use of certain AWS services, which is not uncommon. But you could also use it to automate things as well. So coming more from the administrative perspective. And last but not least, the concept that we make use of in the AWS in Action book, and we'll also go through that in this series, is infrastructure as code, which basically uses a blueprint to manage your cloud infrastructure. So that basically is another layer of abstraction, and it describes the infrastructure that you want to have, and then translates that into API calls in the background and sends them basically to the AWS API. So this is another powerful way to interact with AWS and with the different services.
Quick question to that. Is this blueprint stuff something where I need to know coding? Like, is this in a programming language, or is this like in a UI, or how can I imagine that one?
Think of it like a descriptive language. So a little bit could compare it maybe to HTML a little bit. So you're describing what you want to get basically. So it's not really a programming language. It's more like a configuration file or like an HTML file basically.
Okay.
So I wouldn't say it's really programming. It's something in between, I would say. Yeah.
Nice, but it's nothing I can do in the Management Console, or is there?
No, yeah, no. Basically, you spin up an editor or an IDE and type in YAML or JSON files or similar file formats. Okay, so that's basically. So we have been going through what is Amazon Web Services, and I think We covered the most important aspects of that. So that's actually to kick off our AWS-to-go series. So as mentioned, this was covering the first chapter of Amazon in Web Services in action. So I hope you enjoyed the format, Stefan.
I definitely did. Thanks. I learned a lot today, and I'm really looking forward to the future episodes, learning even more.
Perfect. Thank you. And to you, listeners, so did you learn something new by listening to this podcast episode? Then may I ask you for a favor? So first, please tell your friends and coworkers about the cloudonaut podcast, and also leave a review on Apple Podcast or wherever you listen to podcasts. Our work on cloudonaut is possible only because of your support. Therefore, we want to thank Alan Leach, Alex Dupree, Anthony Ratey, Christopher Hipwell, Jans Franz, Jason Shorty, Jeff Finlay, Jens Gehring, Jay Hordley, Johannes Krumbrück, John Culkin, Jonas Melquist, Georgia Matinka, Camille Oboril, Ken Snyder, Ross Mohan, Simon Naga, Satendra Sarma, Sean Toledano, Thorsten Höger, Todd Valentine, Victor Granu, and all anonymous supporters. With your help, we can continue to produce independent and high-quality content focused on AWS. If you're not already doing so, please consider supporting us with a one-time or recurring donation as well. You will find all the details in the show notes. Thanks for listening. We'll be back soon. Bye.